All right, folks, let's get started talking about programming. To program requires a programming language, some language in which you can write the instructions or the rules or just the functionality of what you want your programs to do. There are lots of different programming languages, and they tend to be specialized for different kinds of purposes. Python, which we'll study, is a general purpose programming language. It's meant to do a variety of different things. There are some languages that are written specifically for logical operations. There are some languages written specifically for scripting and doing operating systems level sort of stuff. There are lots of different options. A general purpose language like Python is intended to be able to be used for a variety of possible uses and to have a lot of different functionality available to you and be extendable as well. And we'll see all of that as we get further into looking at Python. There are always trade-offs when we choose a programming language. For instance, some do certain operations faster than others, and some do things in sort of an easier syntax or sort of an easier to read or write kind of way. Some languages do things for you in the background that other languages would require you to do manually, for instance. There are some languages that are more powerful in the sense that you have a lot more options available for what you can do versus some others that are a bit more restricted because they try to make sure that everything you do is safe. For example, there are languages that are often used for banking software and a lot of kind of manufacturing devices. Those languages have a very restricted set of operations available, and they're designed in a way so that code you write will always absolutely follow the rules that are set aside for that language. Other trade-offs that we might have is how readable the programming language is versus how full-featured it is, or lots of different things that you might lose with that readability. How many different options do you have for ways to do things? So Perl, for example, is a programming language that's notorious for having lots and lots of different choices of how to do things, but because there are so many different ways to do things, this makes it harder to read because the way that you thought of to do it and the way that I thought of to do it will read completely differently. And so that can make it a bit of a challenge to share code between different programmers. There are also what we would call programming language paradigms that different languages follow. For instance, Python will tend to execute lines of code sequentially. It does line 1, and then line 2, and then line 3, with some exceptions that we'll see. Other programming languages might be written in ways where things are just one big long statement, or that parentheses are used to determine the ordering of things. Lisp is a programming language that tends to use lots of parentheses to group things into one big statement, or another way to think of it is very large lists of different operations that are going to be done. There are other programming languages where you write everything as rules and logical statements, and then they try to make your data conform to those rules or to sort of follow those rules of what to do. In most programming languages, you will have basic arithmetic operations so that you can do math, addition, subtraction, multiplication, division, for example. Most of these are pretty standard, and it's usually pretty predictable what's going to happen when you do plus, minus, or times, for instance. I will make note that you should pay attention to division in programming languages because, as you have seen in math classes, dividing whole numbers may result in decimal numbers, or you may follow some different rule to always keep it to be whole numbers. And so division can sometimes be a little unpredictable, but otherwise, you're typically going to have your basic mathematical operators as you would expect them. And to be able to do those operations and to be able to have our programs run with some data, then we will often define variables. So our programs typically need data as input, and they will often result in some data as an output or an outcome of the program, and that data usually lives in variables. There are many different analogies for what a variable is or what it does, and they all have their ups and downs to them. One way to think of variables is that a variable is a label that's attached to a value. For example, the number 14 is a value, and I give it the label or the name x in this example that's shown here. And that's one way that we can think of variables. Sometimes people find it useful also to think of variables like a box that you can put data into, and that box can hold one version of that data, one value for that data at a time. That's another analogy that's useful in some ways and will mislead you in other ways. But thinking of variables as names or labels that are associated with some value is a perfectly good way to think about variables. And we'll kind of challenge your understanding of variables on and off throughout the semester as we dig deeper into what data can be and how things are stored in programming. Examples of things that we might assign to a variable are numbers, whether those be whole numbers, decimal numbers, etc. Characters, meaning like the letter A or the number 2 represented as a character so that you could print it out or put it together with other characters, or the exclamation point. And another example is strings, which are sequences of characters like the word hello. So here we've assigned the string CS128, and we've given it the variable name user_name. The variable name that's getting associated with a value is going to be on the left-hand side of a statement, and the value that is being assigned that variable name or assigned to that variable name is on the right-hand side of the statement. People often switch these around, and in something like math, that's perfectly fine. If you say x equals 3 or 3 equals x, those are equivalent. But in programming, we almost always, from what I've seen, are going to have the variable name on the left and the value on the right-hand side. Here are some more examples of variables and using them, and in particular, assigning them to values. So x gets to be the name for 16. Sometimes people read these statements as x is 16. That's a little worrying sometimes because that sounds like a logical assertion, which is not exactly what we're saying here. I like to say it as x gets 16 or x is assigned 16. The variable that's being given a new value is on the left, and then whatever we put on the right-hand side is what will be the new value that has the variable name y, for instance, in this example. So y is the variable name, and it's getting x assigned to it. Now, the trick to this is where you use x, the programming language, as it runs, will look up what x currently means. So this is similar to how in regular speech we use pronouns or we use other sort of references for people. I found the cat, he was in the garbage, whatever. The he there, you and I know, refers to the cat. And in the same sense, the programming language will be able to reference whatever X currently is and say, yeah, look that up. Oh, it's 16. All right, well then Y gets 16 as well. And similarly down here, A gets 23. And then A gets whatever B is. So this is saying, look up what B currently is, which we didn't define here. Let's hope that it was defined somewhere else in the program. And then A gets to be the name for whatever that value is that B was. This, by the way, replaces what A was referencing before. So A was referencing the number 23. And then if B has something else as its value, now A is referencing that, whatever B was holding or existing as a name for, the number 5 or the word cat or whatever. This does not change B's value. It only changes the value for the variable name on the left-hand side here. And that can be important to pay attention to as well. So here's another sequence of variable assignments and things being used. So A gets 23, C gets 4, then C gets A, and then A gets 5. So it's worth taking a moment to stop and think about what would be printed out if you ran this program. If I said print out whatever A is the name for and whatever C is the name for, then what would be the things? What is A naming at this point in time? Remembering that Python executes a line, then moves on to the next line and executes it, then moves on to the next line and executes, and so on. And likewise, what would C be naming right now? So if you can, you might pause the video and think that through and make sure that you're really solid on your understanding of it. Now to step through it here, A becomes a name referencing the number 23. C becomes another name for the number 4. And then here I am saying, make C instead be a reference for whatever A is. So now the programming language would have to look up, what does A currently mean? What does A currently equal or have a reference? Well, A has 23 as its value right now. So C becomes a reference to the number 23 as well. Then down here, I say, now make A be a name for the number 5. Make A reference the number 5. So that changes A. Because these are simple values, it does not change C. When we're dealing with numbers in particular, and other really simple values, just because you said C equals A before, that does not mean C and A are the same forever, and changing one of them would change the other. So here when I change A, it doesn't change C, it just changes what A references. C can still reference the number 23 where it was assigned before. So A will be 5. When I print this out, it will print out 5, and it will print out 23 because C was assigned that value here on this line, C equals A. While we're on the note of printing, there is a built-in print function in Python. It will display whatever is in the parentheses after that, and it's useful for seeing the value of things. So we will often use these to be able to display what's going on in your program because you can print out a variable and see what its actual value is in that moment. If it's not what you expected, then you can look back through your code and figure out why and where it got whatever value it does have. If it is what you expected, that's helpful and it confirms things. It can also be a really useful thing for sending information to the users of our programs. If someone runs our program, we can print things to give them some output or some feedback on what's going on in the program. I want to point out that you will see Python examples that have print without the parentheses. Earlier versions of Python had a print function that it was sort of written special and it didn't use the parentheses. Since Python version 3, you do have to use parentheses with print, and so you'll see sometimes examples that go either way. Don't be too surprised or thrown off by that. All right, so the most complicated type of data that we're going to deal with for the first little while here is strings. They're pretty simple to you and me to be able to write out a word or a sentence or a paragraph or things like that. All of those can be represented in a program as a string. Any sequence of characters can be a string. So hello is one example. This 234-19-KL5, that's also an example of a string. It is just a value, like numbers when we look at them, like characters, like lots of other things that we're going to see, and therefore they can be represented with variables. So you can write a single variable name that could represent the string that is the entire text of the book War and Peace. It's perfectly fine to do that because all of that long sequence of characters is a string. When you put strings into your program as values that you want to assign to a variable or that you want to print out or things like that, you will put it into quotes. That's how we know that it is an actual value that we're using, not a variable. For instance, I could have a variable named hello. Its name would not be in quotes. So down here we see the string hello is used, and we know that it is a string and it's therefore a value that can be stored as a variable because it's inside of quotes. And so here we have an integer variable set to be 15, and then another kind of number, a decimal number variable that's set to be 4.5, a string of hello, and a string of CS128. We could print the two strings using two print commands, or we could use a single print command. Either one will work just fine. So overall, what we've seen is that programs have to be done in a programming language. The Python programming language uses sequences of instructions, single line instructions, that tell it one thing to do, and then the next, and then the next, typically, with some exceptions on how we structure things that we'll see later. And that to have data for our programs, we need variables. Variables are sort of like math variables in that they are a name that can be associated with some value, but they're also a little different because those values can be changed over time. A variable can't represent multiple values at once, like math variables can be used to do, and those variables can hold a lot more than you would typically work with in mathematics, like strings, for example. And so we'll continue to use variables and see them in different contexts and even kind of challenge some of the ideas that we've simplified as we've looked at variables today.